All right, guys, it is time we state Newton's universal law of gravitation. Now, Newton's universal law of gravitation states that every body in the universe attracts every other body with a force directly proportional to the product of their masses and inversely proportional to the square of their distance apart. This law is a universal law. Everybody in the universe, including bodies on Earth. Yes. You see this law I just stated, Before Isaac Newton, when religion was dominant in the world, okay? You know, religion made people to believe that the heavenly bodies, they are being governed by a different law, and those laws are perfect. Do you understand? That the laws on earth is not the same. The same laws that govern things on earth is not the same law that governs things in the heavens. Okay? The heavenly bodies, you know them, the sun, the moon, and the planets. Isaac Newton came and said, no, that the same laws that govern objects on earth is exactly the same law that governs what? Objects or bodies in heaven. So this law is a universal law. Do you understand me? So the law has philosophical implications. In fact, it changed the mindset of philosophers and all these religious men. It changed Newton's his laws of motion and his law of gravitation. It changed, in fact, it changed human mind, like human perspective about the cosmos and the universe in general. Yes. So I'm telling you this for you to know how powerful that law is. That's why they call it Newton's universal law of gravitation. So now see, the force is directly proportional to the product of the masses of the bodies, and the same force is inversely proportional to the square of their distance apart. So force is equal to GMM, or let me write the joint variation first. F jointly varies as what? Mm over what? R squared. Therefore, putting a constant, F is equals to what? G mm over what? Over R squared. This G is called what? The gravitational constant, which is equal to what? 6.67 times 10 raised power minus 11 Newton meter squared per kilogram squared. This is gravitational constant. This constant measures like the amount, that is the amount of the attraction. Do you understand? This constant now, yes, the amount of the attraction is constant everywhere in the universe. If you increase this constant, let's say by the factor of 10, my dear, the earth can crush you. Like you can't even walk on this earth. It's not possible. Do you understand? So this is Newton's law of universal gravitation. This law simply means that gravity obeys inverse square law. Do you understand? You guys know that. You know that like from here, F equals to GMM over R squared. All these are constants. Okay, GMM. No, they are all constants. So we now have F is equal to this constant GMM. Let me separate it. Okay, GMM times 1 over R squared, constant. Okay, so that means the force obeys, that is, the variables are the force and the radius. Do you understand? So that's why they say gravity, or the gravitational force of attraction, it obeys inverse square law. So in our next topic, we focus on this, on the inverse square law of gravity itself. Yes, you will now see why different orbits around the planet, say Earth, have different values of what? Gravity, gravitational acceleration on them. Okay, like this on Earth here is about 9 9.8 meter per second squared. Do you know what this thing means? Anybody that is falling, falling, once it at that point that it touches the surface of the earth, that point, the acceleration at that point is what? Approximately 9.8 meter per second squared. Okay, see you guys in my next video.